Hi, my name is Marshall Kane. I found art assets and sound effects, as well as editing these assets to match our game. I also worked on level design and balancing of our main level.
Hi, my name is Fuad Diff, and I worked on initial level design and creation, as well as creating the main menu, the game and the game over screen, and setting up the animations for the player and the skeletons.
Hey, my name is Jorge Varela and I work mostly on the player controller, the AI framework for the boss and the skeletons in the game.
Shadow Strider is a game where you play as an unnamed warrior persona of the main character trapped inside their mind. The dream world has been invaded by dark forces, and it's up to you to fight the bosses of the castle in order to vanquish the darkness. So the first level is set in a dungeon, the depths of the castle, and the first boss you encounter is the Summoner. The inspiration for this game drew upon depression and a feeling of losing control during this dark time.
The main enemy of Shadow Strider is the skeleton. Skeletons patrol in a set pattern, keeping an eye out for the player. If he sees the player, the skeleton will give chase and try to attack the player. There are three types of skeletons: Standard, Titan, and Crimson. Standard skeletons take 5 hits to kill. Titans can reach much further and can take 10 hits, but they are slower. Crimson skeletons are very fast, but they only take 3 hits to vanquish. While skeletons can be killed, this death is not permanent. After 5 seconds, the skeletons will come back to life and return to patrolling.
Most of my work took place around the AI for the skeleton and the boss. The skeleton AI is a finite state machine that works between 2 stages, passive and aggressive. The stages depends if the skeleton is able to see the player. When a skeleton is in a passive stage, it will walk in a specific path that can be easily modified on implementation. If the skeleton has the chance to see the player, it will switch to an aggressive stage. It will go and kill the player. Skeletons can evade obstacles by using raycasting. This also means that it cannot see the player if it's behind an obstacle. The skeleton can switch from aggressive stage to passive if the player stays away from its vision range. I also work on the AI for the boss. I tried to make it difficult enough that the player wouldn't be able to beat it in the first try. The boss will teleport to specific locations in the map, fire projectiles to the user, and revive skeletons. All of these choices are made using filter randomizers. Also, the boss difficulty will increase the longer it stays alive and the lower his health goes.
For development, we considered using Unreal Engine 4, but we went with Unity because it doesn't require as powerful a machine to run and to test the code. For source control, we also debated using GitHub to put all our code in as backup, but our group size was the perfect limit for Unity's built-in collaboration tool, so we went ahead and used that because it made it very easy to push and pull changes and get it instantly.
Fuad and I first brainstormed this idea for our game pitch. During development, we had informal testing to guide our project. I showed my good friend and roommate our ideas and game through the early stages of development. He helped to give us an outside perspective of what worked and what didn't. Later in development, we spent a lot of time developing in Meta UF. While there, we asked some of the other students there to test our game. They gave us feedback from a developer standpoint, such as which features were infeasible for the scope of our project. Because of all this feedback, our final product ended up looking very different from our original ideas. Features such as a smoke dash and throwing shurikens were cut. However, we are still happy with the final result.